So that's kind of a good segue to talk about what's being done here from a water quality standpoint. And so at this site, we're monitoring the quantity of water coming into the storage pond. We are taking daily water samples of that for nitrogen and phosphorus, and then we're taking samples from the storage area itself for nitrogen and phosphorus, and then monitoring the quantity of the water leaving the pond and collecting nitrogen and phosphorus samples for that. We started to do that in 2022. The nitrate concentration coming in is fairly consistent, about 15 milligrams per liter, and then leaving the pond area, it's about 9. So we're seeing 30 to 40% reduction in nitrate concentration as that water moves through the pond, and then even if all the water that came in that was leaving, we'd see 30 to 40% load reduction. But in this case, we're also taking a portion of that water and sending it out for the center pivot. So we're getting even greater than that nitrate load reduction with this practice at this specific site. So I think it kind of illustrates the potential for this as a water quality practice in addition to maybe crop performance practice.
Right, and so it's in line with some of our other edge of field practices, but unlike saturated buffers or bioreactors or even wetlands where there's really no economic benefit back to the farmer, this one does have that economic benefit then of that supplemental irrigation and the crop production increase from that. So again, that's a way to incentivize this. It might be a little easier sell than some other edge of field practices, particularly for some farmers. Yeah. And so we've got that additional crop benefit as well.
Maybe one of the things is also to some of these sites, if we get more of them, understand, are there any waterfowl or wildlife habitat benefits around them? They may not have as much buffer area or maybe have, the aesthetic value of the wetland, but there may be some, at least small value of that for wildlife habitat or waterfowl habitat.
Yeah, absolutely. And that's something we can design too as well. And so, depending on how we design and manage the system, we can get some complementary benefits beyond just water quality and crop production. So, if we put some shallow water area in there as well as the deep water that we need to pump out of, then we could create some wetland type habitat. Obviously, we've got the deeper water habitat that does provide some wildlife benefits as well. And then, what we choose to do with the buffer can provide some wildlife benefits as well. And there may be some other opportunities for benefits too, that if we do this at a large enough scale, we've now created storage on the landscape, and so depending on how we manage that, we may be able to have some benefits for downstream flow, flood peak reduction as well. So I think there's opportunities depending on how we design and manage these, and that's another open area for research to see how we maximize the benefits of these systems.
Yep. Okay, at this site, as I mentioned, there's a drainage ditch there's a drainage main that discharges as well as surface runoff. That comes underneath the road up there, and then there are 3 large culverts that we're monitoring on after that surface and subsurface flow has combined. That flows into the on-farm storage, the pond that we see here. And then there's a large sheet pile weir as the exit. And so there's a normal pool elevation that's controlled by that sheet pile weir. And then that large weir, allows for a lot of water to pass through if they get a very big runoff event here with minimal bounce of the system. The intake for the sump is down toward the bottom of the storage pond, so they can access as much storage volume as they can. So with this more managed system, the irrigation system, would it allow the farmers to think about maybe more fine-tuning their management for their crop, or thinking about how they do nutrient management for crop production? Does it open up any opportunities there?
Yeah, so certainly we're recycling nutrients that are in that water back into the field. Now, what's in the water, both the concentration and the amount of water that we put on. It's probably not going to change the overall amount that they're going to apply because it's going to be fairly insignificant relative to the crop needs. But what it does open up is some additional management capability that they didn't have before, because now we've got that irrigation system. And so it opens up the idea of fertigation, where we could be applying nutrients through that irrigation system throughout the year. And so where we may be limited to a fairly narrow side dress window for traditional side dress, now we can use that irrigation system to put on nutrients, when all through the crop season. So it really does open up some management capability that we didn't have before to really fine tune that nutrient management and really only apply what's needed when it's needed.
And have the water there to move that to the plant root zone. Because I know we have a case in Northwest Iowa in 2017 where we side dressed in early July, but then only got an inch of rain in the month after that, and so that nitrogen that we applied never got moved to the plant root zone. So with this, we know we have the water to move that nitrogen into the plant root zone.
And controlling that water gives you some other management capabilities as well. So, if it turns out to be a dry spring, you've got some water if you need to help germinate a crop. And then likewise in the fall, if you're trying to establish cover crop and it's dry, we know the challenges of trying to establish cover crops when it's too dry. And this year was one year that illustrated that in a lot of locations. And so having some water to get that cover crop germinated and established can help with that aspect as well.
And so one of the other things is, perhaps if we had some of these systems, it might be easier to implement some of the intercropping, relay cropping type systems where we maybe have a small grain followed by soybeans, that maybe there's some concern about deficit water stress for that soybean crop, but now we have water to really help that crop get through the growing season.
Yeah, absolutely. And again, that's another way to kind of intensify that system and create some more value that supplemental irrigation can help provide. I think of another aspect would be seed corn production or things like that as well, seed production, where you want that guarantee that you're going to get a good yield or good be able to fulfill those contracts. And so having that water gives you that ability to be a little less worry about the risk of losing some of that crop.
Chris, we have many edge of field practices. I think there's a lot of potential with this practice. Where do you see as some of the research needs, and maybe where do you see we are as far as seeing more of this out on the landscape?
Yeah, certainly, a lot of the research is still really around the costs and benefits of these systems, and so I think we've at least got a pretty good handle that yes, we are going to see a yield benefit from supplemental irrigation. Now the question is that enough of a yield benefit to pay for the system? And I think right now it's pretty clear that probably good chance we can pay for the irrigation system. It's probably not likely that we're going to be able to pay for the storage unless it's a really high value system. So then we really need to get a handle on what are the public benefits, the water quality benefits, and so what's the value of those, and then how can we pay for that to get those benefits. And so certainly a lot of questions around the economics. Then again, some of the management, how do we best manage these systems to get the maximum benefits both for crop production and water quality, and then any other benefits that we design and manage the system for. So those are probably the main research benefits. We do have we worked with NRCS to get a conservation practice standard at the national level. So if Iowa chooses to adopt that standard, then it becomes EQIP eligible. So that's one way to start paying for some of these systems. Iowa Department of Ag and Land Stewardship, IDALS, has also shown interest in this idea in these systems as well. And so right now, there's some potential to get some help with the storage side of the equation for some cost share assistance that way. So that can help get some of these early sites up and going. And then as we learn more from more sites, then hopefully that allows us to continue to continuously improve and get more sites going so that we can start to scale this practice up.
Yeah, I think that's a good way to think about it, is that this may not be something that there's that we want to we're probably not going to be able to do all the practices with state and federal dollars, but especially in the early stages of this, trying to get some help for the farmers to put them in to understand it, then hopefully it might be able to scale up after that if we can see the benefits to the crop production, and maybe there is some ecosystem service benefits and future payments for ecosystem services that help with that.
Yeah, I think those market-based approaches may be the wave of the future as a way to really incentivize these, and with the storage and the whole system, we've got a lot of ways that we can actually measure and quantify those benefits and have real verifiable outcomes to be able to market that way.
Yeah, sometimes some of these engineered solutions are a little bit easier to quantify the benefits of, because we have a pretty defined inflow point and outflow point that we can measure and quantify what's coming in and what's going out, and the rate at which it's coming in and out.
Yep, absolutely.